Find the distance and the direction of the vector. Now, let's find the distance. Note, we are going to use Pythagoras theorem. And our vector is A, so we have position vector A equal to the magnitude. This time around, my x is 3 and my y is 4. So we have what? 3 squared plus 4 squared. When we point this one, we get what? 25. Then the final answer will give us what? So this one becomes my distance for this one. Now let's move on to what? The direction. For the direction, let's draw this one first. If we have this, our y and our x, remember here is what? The north. And when we are asked to plot this one, 3, that means 3 is here on x-axis, and here becomes our 4. So here and here, 3 and 4. When we decide to plot, they meet at where? This place. We have to draw right angle triangle on the x-axis, always on the x-axis. Here becomes what? Our 90. From here to here is 4, therefore here is also what? 4. Now, we need the angle here. Let's call this angle alpha. Let's redraw this one. It has become something like this. 3 and 4. Finding the angle alpha, we are going to apply what? The trig ratio rules. We have what? So, cut and 1. This one opposite hypotenuse, adjacent hypotenuse, opposite adjacent. Now, let's stand here. The angle here, alpha, is opposite to what? 4. So the 4 is what? Opposite. What about the 3? The 3 is adjacent to what? The angle alpha. So here is what? Then here becomes what? Hypotenuse. Always side. It is what? The longest side. So which one are you going to use? Yes, we will use what? What? Which is what? Tan. So we write tan alpha is equal to opposite, which is what? 4. Adjacent 3. We send tan to the other side. Then we have alpha equal to tan inverse of 4 on 3. When we run this one, we get 5, 3, 1, 3, 0, 1. Let's try to run this one to the nearest. When we run this one to the nearest, we have what? 5, 3, 3. But note, this is not our final answer. It is the angle which is here, which is what? 53. But the bearing starts from here, the direction. It started from the north. So it reads to this place. Therefore, we have to find the angle here. So the angle here, let's name it what? Theta. So if we have this one, it means what will be the angle here? Therefore, we can conclude the direction will be equal to, from here to here is 90 minus what? The alpha. And 90 minus the alpha is what? 53. Therefore, we can conclude to say that The final answer will be what? 37 degrees. But since it's a direction or a bearing, we need what? 3 what? Digits. Therefore, it will give us what? 037 what? Degree. 037 degree. Now, let's solve the second question, which has what? Negative in it. Second example. Find the magnitude and the direction of vector xy. -5, 9. Correct to nearest whole number. Now, let's find what? The magnitude. Let's say I, magnitude. Note, we are going to use what? Pythagoras theorem, where it states that. So we have to know our x and our y. So here, our x is -5 and our y is 9. Magnitude of xy equal to root of our x is what? -5 squared. Then plus 9. So let's point. When we point this one, it will give us 10.2956. But the question is saying that to the nearest what? Whole number. So when we run this one to the nearest whole number, it will give us what? 10. Then we add what? Unit to it. This is the magnitude or the distance of the length of xy. Let's move on to find what? The direction. For the direction, we have to draw to see where it will fall. Remember, here is our north. That's where y is. And here is our x. But note, our x is -5. Where will it be? It will be here, negative. So from here to here, let's turn this one to be -5. And the y is 9. Still, it will go out. So from here to here, let's say it is 9. So the 9 and -5 will meet at this place. Then we draw to where the bearing is. Always note, we draw right angle, triangle in line with the x-axis. So here becomes what? Our 90 degrees. Note, from here to here is 9. Therefore, I can say here is also 9. Here to here is what? -5. We need the angle which is here. Angle alpha. Let's redraw this one for more understanding. When we draw it, becomes something like this. Where here is 9 and here is what? -5. But since we are going to calculate +5, then ask yourself, the 9 and the alpha, what is it doing? Here is what? Opposite. What about the 5? It is what? Adjacent. And this will become what? Hypotenuse. Remember that we are going to use what we call SOHCAHTOA, the trig ratio. So, ka and toa. What is given in the question? Opposite and adjacent. Therefore, we use what? Toa. Can we say tan the alpha equal to the opposite, which is what? 9 divided by the adjacent, which is what? 5. Let's send the tan to the other side. We have alpha equal to tan inverse 9/5. Let's punch this one. This one on the calculator, we have 60.9453. Let's run this one to the nearest whole number. When we run this one to the nearest whole number, you get what? 60 what? 1. No, because the angle that we have gotten here is 61. But we need the bearing from this place up to that place. So we ask yourself, from here to this place, what 270 degrees. From here to this place is what? 270 degrees. But we need this one in addition. So we add 61 plus. Therefore, we can see the direction will be 270 plus the alpha. So when we add the 270 plus the alpha, we will get the total bearing for anything. Then, can we say 270 plus 61? Well, 270 plus 61. When we add 331 degrees. This becomes our direction. This becomes our direction for the question given. Try to solve the following question.